So good morning, all of you. So today we will learn rational numbers. Okay. Well, what is rational number? What is the need of rational number? Okay. First, let us see. Let us see one equation. All right. Let us take twice x plus 5 equal to 0. Suppose. Okay. Then if you solve it, what you will get? Twice x equal to minus 5, x is equal to minus 5 by 2. So the solution of this equation is not a whole number, neither an integer. So it is a different number. It is a rational number. This type of numbers are called rational numbers. Now, how to define a rational number? Okay, how will you define the rational number? So while solving this equation, we got a different type of a number. So this type of numbers are called rational number. Now, what is rational number? Rational number. Okay, a number, a number which can be expressed in the form p by q, where p and q are integers and q not equal to 0, is called a rational number. So a number here, this is p, this is in p by q form. You see, this is in p by q form. All right. So it is a rational number. All right. It is a rational number. Okay. So a number which can be expressed in p by q form is called a rational number. So the numbers like, for example, 2 by 3 minus 5 by 9. Okay. We can write 5. 5 can replace 5 by 1. 0. 0 can replace 0 by 1. Okay. Are all rational numbers. Alright, these are all rational numbers. Okay, now let us go to this that I had already written here. A number which can be expressed in the form p by q, where p and q are integers and q not equal to 0 is called a rational number. These are the examples. So 5 can be written as 5 by 1. It can be minus 9 by 1. Okay, this can be 0 by 1. So these all are rational numbers, right? Okay, these are a number which can be expressed in p by q form is called a rational number. So natural numbers are rational numbers, whole numbers are rational numbers, integers are also rational numbers. So all the numbers, whatever we have learned till today, are all rational numbers. Alright, now let us discuss some properties of rational numbers. Okay, now you see, first, before starting rational number, let us see for whole numbers. Okay, for whole numbers, closure property we will discuss. Say, so you take two whole numbers. If you add two whole numbers, the answer is a whole number, right? You take another two whole numbers, the answer is also whole number. So if If A and B are any two whole numbers, their sum is also a whole number. Their sum is also a whole number. So, whole numbers are closed under addition. If sum of any two whole numbers is again a whole number, then it is said to be closed under addition. Okay. Now let us see subtraction. If you take any two whole numbers and subtract one from other, then difference is minus 2. Okay. Is it a whole number? No, it is not a whole number. It is not a whole number. So whole numbers are not closed under subtraction. Alright. Let us see for multiplication. When two numbers are multiplied, two whole numbers are multiplied, the product will also be a whole number, always. The product will also be a whole number. So whole numbers are closed under multiplication. So let us say division. Any two whole numbers you take and divide. Is this answer a whole number? No, it is not a whole number. So the whole numbers are not closed under division. Alright. Now let us see for integers. You take two integers and add, answer is an integer. So any two integers if you take and add, the answer will be an integer. Hence integers are closed under addition. Alright, integers are closed under addition. Now if you take any two integers and subtract, the answer will always be an integer, right? If you take any two integers and subtract, answer will be always an integer. Hence, integers are closed under subtraction. Okay, they are closed under subtraction. Okay, then multiplication. Any two integers you take and multiply, the product will be an integer. Two integers you take and multiply, product will be an integer. So any two integer you take and multiply, product will be an integer. Alright? Okay. So integers are closed under multiplication. Now division. If you divide two integers, the answer may not be an integer. So integers are not closed under division. Here one thing you need to note, you should note is in mathematics, if 99% cases are true and 1% is false, okay, 99% are true, the statement will be false only. Okay, if 99.99 cases are correct and 1% cases are wrong, the statement will be wrong. Okay. Now let us see the closure property for rational numbers. Let us see closure property for rational numbers. Okay. So let us take two rational numbers. Let us take two rational numbers. Let us take 2 by 3 plus 5 by 3. How much? It is 7 by 3. Is it a rational number? This is a rational number, right? Okay, now let us take another example. Minus 5 by 3 plus, okay, okay, instead of 3 you can write is 9, okay, plus this will be 4 by 9 is equal to how much? Minus 1 by 9. Is it a rational number? This is also a rational number, right? So for any two rational numbers, okay, for any two rational numbers, A and B, A plus B is also a rational number. Alright. So if you take any two rational numbers and add them, the answer will also be a rational number. Therefore, rational numbers are therefore rational numbers are closed under addition. Alright, rational numbers are closed under addition. Is this clear, all of you? Okay. Rational numbers are closed under addition. Now let us take subtraction. Suppose 5 by, suppose you take 5 by 11 minus 7 by 11 is how much? Minus 3 minus 2 by 11. Is it a rational number? This is a rational number. This is a rational number, right? Okay. Now, this is a rational number. Now, I'll take another. Suppose 5 by 3 minus 0 you take. It is 5 by 3 only. This is also a rational number. So, if A and B are any two rational numbers, then A minus B also will be a rational number. Therefore, rational numbers are closed under subtraction. Therefore, rational numbers are closed under subtraction. You understood? If you take any two rational numbers and subtract, the answer will be a rational number again. Hence, rational numbers are closed under subtraction. All right. Let us see for multiplication. Let us see for multiplication. Okay. For multiplication, what happens? Let us see. Okay. For multiplication. Okay, for multiplication. Let us take. Okay. Well, for multiplication. So let us take two rational numbers. 2 by 3 into 7 by 9. So how much it will be? 14 by 27. Is it a rational number? This is a rational. This is a rational number. Similarly, take 3 by 5 into minus 5 by 4, suppose. So it will be minus 3 by 4. This is also a rational number. Therefore, for any two rational numbers, A and B, A into B will also be a rational number. You understood this point? So, therefore, rational numbers are closed under multiplication. Therefore, rational numbers are closed under multiplication. You understood the closure property? Now let us see for division. Let us see for division. Okay, you take two rational numbers, 2 by 3 divided by, okay, 2 by 3 divided by 4 by 9, suppose. How we can write this? 2 by 3 into 9 by 4, right? This will be 1 by 3 by 2. This will be 3 by 2. This is a rational number. This is a rational number. Okay, but let us see 5 by 9 divided by 0. What will be this? What will be the value of this? This is not defined. We cannot divide something by 0. This is not defined. This is not defined. Okay, so not defined means it is not a rational number. It is not a it is not a rational it is not a rational number. It is not a rational number. Therefore, for any two rational numbers, for any two rational numbers, for any two rational numbers, A and B, A divided by B may not be. If 99% cases are rational number, but in one case, if it is not rational, then it will not be closed. Okay, A divided by B may not be. Sometime it may be, but in one case when it divided by 0, it will not be defined. Hence, A divided by B may not be a rational number. Therefore, rational numbers are not closed under division. Okay, so what you got? Rational numbers are closed under addition, multiplication, okay, and subtraction, but it is not closed under division. Okay, well, then let us go to commutative property, another property, that is commutative property. Okay, let us go to commutative property. Commutative means, you see, 4 plus 5 equal to 5 plus 4, right? This is commutative property. You have to add this in reverse order or multiply this in reverse order, like that. Okay, let us take this. 4 plus 5 is how much? 9. Okay. Similarly, 5 plus 4 is how much? 9. Hence, can we say this implies 4 plus 5? This implies 4 plus 5 is equal to 5 plus 4, right? So is it true for all the rational numbers? Is it true for all the rational numbers? Okay. So for any two rational numbers, we can write for any two rational numbers A and B, okay, A plus B is equal to B plus A. Therefore, rational numbers are, for any two rational number, A plus B will be always equal to B plus A. Therefore, rational numbers are, rational numbers are commutative under addition. Is this clear? So rational numbers are commutative under addition. Commutative means if you add in reverse order, then also the sum will be same. Then now for subtraction, let us take. For subtraction, let us take. Okay. For subtraction, you take 9 minus, okay, 9 by 11 minus, suppose 4 by 11 is how much? 5 by 11, right? But, and reverse order, let us see, 4 by 11 minus 9 by 11, you do how much? Minus 5 by 11. Are these the same? This implies 9 by 11 minus 4 by 11 is not equal to 4 by 11 minus 9 by 11, right? The reverse order, we cannot, if you subtract in reverse order, then their answers will not be same. Therefore, for any two rational numbers, for any two rational numbers A and B, for any two rational numbers A and B, okay, A minus B is not equal to B minus A. Therefore, rational numbers are not commutative. Rational numbers are not commutative under subtraction. Rational numbers are not commutative under subtraction. So I think this point is clear. Now let us see for multiplication. Okay, let us see for multiplication. So let us take 2 by 7 into, okay, 4 by 11 is how much? 8 by 77. Then you write in reverse order, 4 by 11 into 7 by, into 2 by 7 is equal to 8 by 77 only. So this means, can we say 2 by 7 into 4 by 11 is equal to 4 by 11 into 2 by 7, right? 4 by 11 into 2 by 7. This is true. So for any two rational number, therefore, for any two rational numbers, for any two rational numbers A and B, for any two rational numbers A and B, okay, A into B is equal to B into A. Okay, therefore, sorry, therefore, rational numbers are commutative under rational numbers are commutative under commutative under multiplication. So I think this is clear, right? Okay. So if you multiply two numbers, whatever answer you get, same answer you get if we multiply in reverse order. Well, now let us go to division. Let us see what happens in case of division. Let us take 2 by 5 into 4 division into 4 by 10, suppose. Okay, this will be 2 by 5 into 10 by 4, right? So this is equal to, by this 2 times by this 2 times, it will be 1, correct? Now let us take in reverse order. 4 by 10 divided by 2 by 5. 4 by 10 into 5 by 2. By this, how many times? 2 times. You got it same, right? Okay, we got it same, that is why. So let us take a little different example. Little different. Let us take a little different because both the fractions we have taken same. Let us take it 15. Okay, instead of 10, let us make it different. Okay, then it will be 2 by 5 into 15 by 4, correct? So by this, if you cancel 3 times, by 2 it is 2 times, it is 3 by 2. This will be 4 by 15 into 5 by 2. By 5 if you cancel 3 times, by 2 1 time, by 2 2 times. So it is 2 by 3. Are they same? Are they same? No. So therefore 2 by, this implies 2 by 5 divided by 4 by 15 is not equal to 4 by 15 divided by 2 by 5. These two are not same. These two are not same. Therefore, for any two rational numbers, for any two rational, for any two rational, for any two rational numbers, A and B, A divided by B, okay, commutative, A divided by B, okay, is not equal to B divided by A. Therefore, rational numbers are not, rational numbers are not commutative, under, rational numbers are not commutative under division. Alright, rational numbers are not commutative under division. Alright, okay, well, then then let us go to associative property. Let us go to associative property. Alright, associative. What do you mean by associative property? Associative property. If you take any three numbers like 2 by, let us take three numbers, 2 by 3, okay, 4 by 3, 7 by 3, suppose, okay, 2 by 3, 4 by 3, 7. We have taken addition. Let us add them. You can take negative numbers also, doesn't matter. Okay. Now what we will do, you add these two numbers first and add with this, and here you add these two numbers. Okay. So how much you will get? This will be 2 by 3 plus 11 by 3 is equal to 13 by 3. Correct? So this will be 6 by 3 plus 7 by 3. So finally you got the same number. These two are same. This implies, what does this imply? 2 by 3 plus 4 by 3 plus 7 by 3 is equal to 2 by 3 plus 4 by 3. Okay, then this side. Okay, so it will be 2 by 3 plus 4 by 3 plus 7 by 3. This will be equal. Okay, so whether the bracket is given for the second two numbers or the first two numbers, the answer will be always same. Answer will be always same. Therefore, for any two rational numbers, any two rational numbers, any three rational numbers a, b, and c, a plus b plus c, a plus b plus c. You give bracket here and you give bracket here. Both will be equal. Okay, this will be always equal. Therefore, rational number. This property is called associative property. Okay, therefore, rational numbers are associative under addition. Associative under addition. This property is known as associative property. Alright, under addition. Now, same thing if you do for subtraction, what will happen? Same thing if you do for subtraction, what will happen? Let us see. Okay, same thing if you do for subtraction, what will happen? Let us see. So let us take 2 by 3. Let us take the same number. Okay, 12 by 3, 4 by 3, okay, 5 by 3 suppose. 12 by 3, 4 by 3, 5 by 3. Now, last time we used addition, now we'll use subtraction. And these two numbers you keep within bracket, these two numbers you keep within bracket. Okay, now let us calculate. 12 by 3 minus, how much it will be? Minus 1 by 3, right? Minus 1 by 3, correct? So it will be 12 by 3 plus 1 by 3. So this will be 13 by 3, correct? So this will be 13 by 3. Now this one will be 8 by 3 minus 5 by 3 is equal to how much? 3 by 3 equal to 1. What does this imply? This two implies 12 by 3 minus 4 by 3 minus 5 by 3. This is not equal to, okay, 12 by 3 minus 4 by 3 minus 5 by 3. These are not equal. Therefore, for any two rational numbers, for any three rational numbers, any three rational numbers, for any three rational numbers, okay, A, B, and C, okay, A, B, C, you put A, B minus C is not equal to A minus B minus C, right? This is not equal. These are not equal. These are not equal. So, these are not equal. Therefore, what can we say? Therefore, rational numbers are not associative, not associative under subtraction, not associative under subtraction. Understood? So same way, if we do for multiplication, if you do for, let us take for multiplication, same way you can do for multiplication. Okay, multiplication, let us take 2 by 9, okay, 3 by 7 and 1 by 2. 2 by 9, 3 by 7, 1 by 2, multiply it. You guess this will be equal or not? You multiply these two and here you multiply. Okay, and you see how much it will be? 2 by 9 into 3 by 14, so it is 6 by 2 if you cancel, by 7 times, by 3 if you cancel 1 time, 3 times, right? So it will be 1 by 21. So here it will be 2 by 9 into this if you multiply, this you cancel 3 times, so it will be 2 by 21 into 1 by 2, so this is 1 by 21, right? So what does this imply? This implies 2 by 9 into 3 by 7 into 1 by 2 is equal to 2 by 9 into, no, 2 by 9 into 3 by 7 into 1 by 2. That is, for any two rational numbers, that is, therefore, for any three rational numbers, for any three rational numbers A, B, and C, A into B into C, this division bracket is equal to A into B into C. This is always true. For any three rational numbers, this is always true. Okay, this is always true. Therefore, rational numbers are, therefore, rational numbers are associative, associative under, associative under what? Under multiplication. Under associative under multiplication. Associative under multiplication. Alright. So under multiplication, rational numbers are associative. Now, can you guess for division what will happen? For division, let us take simple example. 2 by 3. Let us take simple example. 2 by 3, 1 by 2, 5 by suppose 7. Okay. 2 by 3, 1 by 2, 5 by 7. Here division we give. So can you guess they will be equal or not? These two and these two. Okay, it is 2 by 3. Okay, divided by this can be written as 1 by 2 into 7 by 5. Alright, so it is 2 by 3, 2 by 3 in, divided by 7 by 10. We can write this as 2 by 3 into 10 by 7. So 20 by 21. So this will be 2 by 3 into 2 by 1 divided by 5 by 7. So 4 by 3 divided by 5 by 7. So 4 by 3 into 7 by 5, 28 by 15. Are they same? Are they same? 20 by 21 is not equal to 28 by 15. Correct? Yes or no? They are not equal. They are not equal. Hence, therefore, for any two any three rational numbers A, B, and C, A, B, C division. A divided by B divided by C is not equal to A divided by B divided by C. Okay, this is they are not equal. They are not equal. So what can we say from this? What can we say from this? Therefore, rational numbers are not associative, are not associative under division. Is this clear? So we have discussed closure property, commutative property, and associative property. Now we'll discuss distributive property of rational numbers. So first one is distributivity of multiplication over addition. Now here, so any number you take 5 into, you take any two numbers like, within bracket you can take 2 plus 3. Okay, you take 2 plus 3 within bracket. Then this can be, this 5 should be distributed given to 2 also, and this 5 should be given to 3 also. That is, it will be 5 into, it will be 5 into 5 into. It should be distributed to both, and here sign will be plus. You understood this point? This property is called distributive property. Distributivity of multiplication over addition. Like 2 by 3 into, okay, 5 by 7 plus 9 by 11. Then this should be written as 2 by 3 should be distributed. 2 by 3 should be distributed to both 5 by 7 and 9 by 11. Then the sign will be same. Is this understood? This property of rational numbers is known as distributive property. This property is known as distributivity of multiplication over addition. Distributivity of multiplication over addition. This sign goes to this place. Alright. Is this clear, all of you? this one. Okay, it will become like this. Well, so for subtraction, okay, distributive of multiplication over, okay, suppose same thing only, 5 multiplied by 7 minus 9, suppose. So how will you distribute? 5 into 7 minus 5 into 9. Okay, 5 into 7, 5. In case of rational numbers also, suppose 3 by 11 multiplied by 4 by 13 minus, okay, 2 by 7, suppose. Then this will be 3 by 7 should be this, 3 by 11, 3 by 11 into, okay, then it will be 4 by 13, it will be 2 by 7, and this sign will go to this place, okay, this sign will go to this place, so like this, okay, it will become like this. So this property of rational numbers is known as distributivity of multiplication over subtraction. Okay, so let us stop here. We have discussed all the four properties: closure properties, commutative properties, associative properties, and distributive properties. Okay, in the next video, we'll discuss few more things. Thank you.